GCSE Physics boosters, changes of state. Remember in the last video we talked about the three states of matter, solid, liquids and gases, and we talked about how the particles are arranged and how much energy they have. This video is about changes of state, when a substance changes from one state to another. Okay, imagine we have some water in a beaker and we heat it up. So it starts at room temperature and we heat it up, and it's going to get hotter and hotter, and eventually the water will start to boil. At 100 degrees centigrade it starts to boil. We keep measuring the temperature as it boils. Now, what will the graph look like? Hopefully you'll have a chance to do this experiment. What will the graph look like? And it'll look like this. So we're starting at room temperature, which will be about 20. We're giving heat energy to the water, so its temperature is going up, and we can use the equation delta E equals mc delta theta that we talked about in the last video. When it gets to 100 degrees, now we're still giving heat energy to the water, but it's not getting hotter. Why not? Because it is changing state. It's changing from a liquid into a gas. Okay, so the first part of the graph there, the water is gaining heat energy. It's gaining, its internal energy is increasing, its temperature is getting bigger. Delta E is mc delta theta. And then here in this second part of the graph, we're giving the heat energy to the water still, but its temperature stays the same. Okay, at the boiling point, 100 degrees centigrade, the temperature stays the same. So where does the energy go? Well, the energy is being used to break bonds. Okay, we are breaking bonds. A change of state is occurring. Now, the energy needed to change a liquid into a gas, it's called the latent heat of vaporization. If the substance is a liquid changing into a gas, then we are giving it heat energy. If the substance is a gas changing into a liquid, then that's condensation. And in this case, this heat energy is released into the atmosphere because the substance loses heat energy. Okay, its internal energy gets less. So latent heat of vaporization applies to this change of state, from a liquid to a gas or from a gas to a liquid, the latent heat of vaporization. The specific latent heat of vaporization, specific means per kilogram. So it's how much energy is needed to change a kilogram of liquid into a gas. So the equation is E equals mL. E is the energy, M is the mass in kilograms, and L is the latent heat of vaporization. For example, to change a kilogram of water into steam, you need 2,260,000 joules for every kilogram. Here's a little sum we can have a go at. How much energy is needed to evaporate 0.7 kilograms of water, which is already at 100 degrees centigrade? And the answer is, so E equals mL, so 0.7 times the latent heat of vaporization, and that's the answer. Now, the other change of state is when a liquid changes into a solid or a solid changes into a liquid. And again, it's latent heat, but it's latent heat of fusion. Look at this graph here. Imagine we had some chocolate, a load of chocolate that were put in the microwave, so it's all melted. Melted chocolate cooling down. Now, melting chocolate, molten chocolate cooling down, what would a temperature against time graph look like? And you'll see here the temperature goes down because it's losing heat energy to the surroundings. When we get to about 40 degrees centigrade, it's still losing heat energy, but its temperature is staying the same. Because the melting point of chocolate is about 40 degrees centigrade, there's a change of state occurring, and eventually it will have all changed into a solid, and then the solid will start cooling down again. Okay, the first part of the graph is a hot liquid cooling down, so that's MC delta theta. The middle part of the graph is where the liquid changes into a solid. At this point, we'll have a mixture of liquid and solid. Bonds are forming, energy is being released. And then when it's all changed into a solid, we have a solid cooling down. The specific latent heat of fusion, again, specific just means per kilogram. So it's the energy needed to change a kilogram from a solid to a liquid, or if a kilogram changes from a liquid to a solid, it's the amount of energy released. For example, the specific latent heat of fusion of water is 334,000 joules per kilogram. Have a go at this little question. How much energy is needed to melt a 30 kilogram block of ice? So E equals ml, and it's just 30 times 334,000, that should be, and that would give you 10,020,000. Here are some sums for you to have a go at. Now be careful that the first one, John puts 2 kilograms of water in a pan, puts it on the cooker, he comes back sometimes later and half the water has evaporated. How much energy has been given to the water? So bear in mind the energy you need to heat up the water, and then when it's boiling, then we need to change it into a gas, and we're only doing that to half of it. And so have a go at that yourself. In the second one, the ice lolly is taken out of the freezer, so the ice lolly is gaining energy from its surroundings. Now, to start with, it's ice warming up, so MC delta theta, and then it's ice melting, so E equals ml, and then it's water warming up to room temperature. Have a go at these. I'm going to show you my answer in 3, 2, 1. Okay, and hopefully you got the same answers as me.